What if I told you that while we've been staring at distant, unreachable exoplanets for signs of alien life, the real mystery has been hiding in our own backyard? We've always viewed Venus as a hellish, volcanic wasteland, a place where the heat would melt your shoes and the pressure would crush you like a soda can. But a controversial new discovery suggests that something else might be thriving in those toxic clouds. Could there be a living, breathing biological soup floating just a few light minutes away from Earth? Welcome to SciNova. Today, we are diving deep into one of the most polarizing debates in modern astronomy, the Venusian Phosphine anomaly. For decades, the consensus was simple: Venus is dead. It's too hot, too acidic, and too crushing for anything to survive. But the data is starting to tell a very different and very strange story. We aren't just talking about speculation anymore. We are talking about chemical signatures that shouldn't be there unless something or someone is making them. So, what exactly did scientists find? It all centers around a specific gas called phosphine, or pH3. In the harsh, oxidizing atmosphere of Venus, phosphine is incredibly unstable. It shouldn't hang around for long. However, independent analyses of archival data from the Venus Pathfinder mission have detected this gas at levels of a few parts per billion. Now, a few parts per billion might sound like a tiny amount, but in the world of astrobiology, even a tiny trace of a forbidden gas can change everything. Now, let's pause for a second and address the elephant in the room. Does phosphine equal life? Not necessarily. On Earth, phosphine is a massive biosignature because it's primarily produced by anaerobic bacteria in environments without oxygen. But in space, we have to be careful. While the presence of phosphine is considered a potential biosignature, it is absolutely not definitive proof of life. It could be a weird, unknown geological process or a strange chemical reaction we just don't understand yet. But the fact remains, it's there, and it's weird. The scientific community was initially skeptical, and rightfully so. When the first reports of phosphine came out, many researchers looked for ways to explain it away using traditional chemistry. But the mystery deepened when independent teams began reanalyzing archival data. They found the same signal. This wasn't just a fluke or a single bad sensor reading. The detection has been supported by independent analysis, meaning the signal is robust enough to merit a serious, high-stakes investigation. If this is life, what kind of life are we talking about? We aren't looking for little green men in flying saucers. We are looking for extremophiles, microscopic organisms that can survive in conditions that would kill almost anything else. Imagine tiny, single-celled microbes floating in the temperate layers of the Venusian atmosphere, far above the crushing surface. They would be living in a world of sulfuric acid clouds, fueled by a chemistry we are only just beginning to grasp. It's a biological soup suspended in the sky. But here is where the theory gets truly mind-bending. Where did these microbes come from? Some scientific models suggest a theory called panspermia. This is the idea that life doesn't always start where it lives. It's possible that life actually originated on Earth. Imagine a massive asteroid impact on Earth billions of years ago, ejecting rocks and organic material into space. Some of that material could have been flung toward Venus, eventually finding a way to survive in the clouds. The math behind this is fascinating and a bit humbling. Models suggest that if life exists in Venus's clouds, it could potentially have originated from Earth via this panspermia process. However, the survival rate is incredibly low. Some models suggest life could potentially exist in Venus's clouds for at least a few days per century if it originated from Earth. It's a slim margin, a cosmic lottery where the winning ticket is a microscopic organism surviving a journey through the void. So, how do we move from maybe to definitely? We need to stop guessing and start sniffing. This is why a major UK-led mission is currently being planned. This isn't just a flyby, it's a deep dive investigation. The mission aims to specifically search for the presence of phosphine and ammonia in the Venusian clouds. By mapping these gases, scientists hope to determine if they are being produced by biological processes or if they are just part of a complex, non-living chemical dance. This mission represents a pivot in how we explore the solar system. For a long time, the focus was on Mars, the red planet that looks a bit like a desert version of Earth. But Venus is offering a different kind of challenge. It's not about finding ancient dried-up riverbeds. It's about finding active, current, biological signatures. If we find even a trace of ammonia or phosphine that follows a biological pattern, it would be the greatest discovery in human history. Of course there are skeptics. Many scientists argue that we haven't even fully mapped the volcanic activity on Venus's surface. It's possible that massive, undetected volcanic outgassing could be pumping phosphine into the atmosphere from below. We might be looking for life when we should be looking at geology. This is the beauty of science. It's a constant battle between competing hypotheses, and every piece of data is a weapon in that fight. Imagine the implications if the skeptics are wrong. If we confirm that these gases are biological, it means life is much more resilient than we ever dared to dream. It means life isn't just a rare fluke that happens on perfect Earth-like planets. It means life is a cosmic opportunist, capable of clinging to the edges of the most hostile environments in the universe. It would change our place in the cosmos overnight. The search for life on Venus is a reminder that the universe is much stranger than our intuition allows. We tend to look for things that look like us, or things that feel comfortable. But the real secrets of the universe are often hidden in the impossible places, in the crushing heat, the toxic clouds, and the silent voids. Venus might be a hellscape, but it might just be a living one. What do you think? Is Venus a dead rock, or are there tiny microbes dancing in its clouds? Let us know your theories in the comments below. If you enjoyed this deep dive into the mysteries of our solar system, make sure to hit that subscribe button and turn on notifications. We're constantly exploring the frontiers of science here at SciNova, and you won't want to miss what's coming next. Thanks for watching!